All right, so we are still dividing polynomials by factoring. And remember, this fatty P just stands for polynomial. And we want to do this by factoring. Last time we learned the technique ME, or monomial extraction, which stands for factor out the greatest common monomial factor. I don't like to say all those words, so I call it ME. Whenever we're factoring a polynomial, there are different techniques for polynomials that take on different characteristics. So when we were factoring by extracting a monomial, we just look at the greatest common monomial for each term. The next method that we're going to look at for factoring a polynomial is we're going to look at factoring a special kind of quadratic polynomial. I call it mother's face, or MoFa for short. It's actually called the difference of two squares. And what it means, if I have some number squared, one term is squared, and I subtract from it the second term, which is just some number squared. And A and B can be variables or numbers. It can be almost anything. The important thing is it has to be something squared minus something squared. This is the pattern that you will just recognize and then do. That's the upside. The upside to this is it's super easy to do. There's almost no work. But the downside is it's a pattern you have to recognize. And that pattern is a squared minus b squared factored is a minus b. Notice it looks almost exactly the same, except I peeled the squares off. And then times a plus b. So let's talk about the names. Even though I use the name mother's face, there is a mathy name and you need to know it. So in the first form, this form is called the difference of two squares. And whenever you see the difference of two squares, then the factored form is the sum. This would be the sum and difference of binomials. So these are like binomials, meaning they have the same terms, except one is plus and one is minus. So it's the product of the sum and difference of binomials. Now, to me, that's a mouthful, so I like having a shortcut name. And the truth is, I didn't make up mother's face. I used to tell kids that they had to recognize this pattern so quickly and so readily. It would be like recognizing their mother's face, and kids started calling it the mother's face method. So I stuck with it because I kind of liked it. But the truth is, it's the difference of two squares. Polynomial can be factored into a product of the sum and difference of binomials. And this pattern in either form, either you see this and think instantly of this, or you see this and you think instantly of this. Super duper important pattern, and recognizing it, sadly, is the hardest part. Doing it is super easy, but recognizing that it's there is the hard part. So let's do some examples so you can practice it. So suppose I have a problem. I'm told to factor a polynomial. I'm told to factor, and the polynomial is 4 minus x squared. So what I'm going to ask myself, I first look at, there's no ME here, right? There's nothing that's common to both of these terms, so I'm not going to extract something, a monomial, a greatest common monomial factor from either term. But I do know that I can ask myself, can I write this as something squared minus something squared? And I think to do that, because I only have two terms and there's a minus sign in between. When I have two terms and there's a minus sign in between, I'm going to ask, can I rewrite it? And in fact, 4 is the same thing as 2 squared, and x squared is obviously the same thing as x squared. And so since I can write it in this pattern, I automatically know what the factors are. The factor is 2 minus x times 2 plus x. Let's check it. So remember, when I say check it, what I'm talking about is, remember we looked at if 6 factors to 2 times 3, we can check this work by seeing if factoring is the same thing as division in polynomials. And then the other direction, multiplication, would undo the division to see if we get back to where we started. And so we want to do that when we check our problem. So I'm going to take 2 minus x, and I'm going to distribute with 2 plus x. So these are my factors. If I multiply them together and get back where I started, then I know I found the right answer. So 2 times 2 is 4. 2 times x is plus 2x. Minus x times 2 is minus 2x. Look at that. Those disappear. And then minus x times x is a minus x squared. These disappear because 2x minus 2x equals 0. And I'm left with 4 minus x squared, which is exactly where I started. So I know I factored properly. Let's do another example. Let's do a squared minus eight. So a squared minus 8, I'm looking at it, it's a binomial. It has a minus sign in between, so I'm going to see, can I factor this? Mother's face method. Well, something squared minus something squared is what I'm looking for. Let's start with the a. Can I write a squared as something squared? I certainly can. A squared is a squared. Minus 8. Can I write 8 as something squared? Is 8 a perfect square of something? It is not. There's no number that I can put in here that would equal 8. Nothing squares to give me 8 except for some wild number, some probably irrational number. But we're looking at integers when we factor polynomials. And so there's nothing that fits the pattern. So this number is prime, meaning only 1 and itself divides it. Let's do another one. Let's look at 4x squared minus 25. All right, again, two terms with a minus sign. Let's see if it's a mother's face problem. Does this equal, can I rewrite this as something squared minus something squared? Okay, so I know you instantaneously saw that 25 is definitely 5 squared. So we're good to go there. This one, well, x squared is definitely x squared, but what about that 4? Well, turns out 4 could be turned into 2, and if I put the 2x inside the parentheses, I would have 2 times 2, or excuse me, 2 squared is 4, and x squared is x squared. I found the a and b values, and so when I factor this, I get 2x minus 5 times 2x plus 5. Let's check it. So 2x minus 5 times 2x plus 5. 2x times 2x, well, positive and a positive is a positive. 2 times 2 is 4. X, I have 1x and one more x, that's x squared. Positive and a positive is a positive. 5 times 2 is 10x. Negative and a positive is a negative. 5 times 2 is 10x. See what happens? Every time that middle term just subtracts out and makes a 0. And then a negative and a positive is a negative. 5 times 5 is 25, and there are no x's. These cancel out, become 0. So I'm left with 4x squared minus 25. And that was where I started, so I know that this is the correct factorization of 4x squared minus 25. So that's factoring the difference of two squares method kind of in a nutshell. But why are we doing this? Remember, we're doing this because we want to divide by factoring. So let's go back to our example of an easy number, 6, which factors into 2 times 3. If I want to divide 6 by 2, I wouldn't do this because I'm already so comfortable with integers and rational numbers, but with polynomials, it's helpful to know exactly what you're doing by comparing it to integers. So one way to divide 6 by 2, or the reason 6 divided by 2 equals 3, is if I were to factor 6 in the numerator, so I have 3 times 2, which is the factorization of 6, and then factor 2 in the denominator, which is just 2. That's as far as you can go unless you want to include 1. But again, that would just get crazy because you'd have to include 1 5 million times. I can cancel these like factors. We've been doing this forever, and I'm left with 3. So 6 divided by 2 equals 3 because 2 is a factor of 2, leaving 1, and 2 is also a factor of 6, leaving 3 after I cancel. So we want to do the exact same thing with polynomials. So we're going to divide x squared plus, whoops, that's not true. We're going to divide x squared minus 16. We want to divide this by x plus 4. So the first thing we have to do first is I can do long division on it, but I don't want to. I want to see if I can just factor it and simplify. So let's look. The numerator looks like it might be a difference of 2 squares pattern. So I'm going to set it up. Can I write the numerator as something squared minus something squared? And if I can, then I'm going to go ahead and do that. And then I have to keep the denominator with me on the journey. So the numerator clearly could be x squared, and 16 can clearly be written as 4 squared, which means I'm definitely dealing with a difference of 2 squares pattern, or the mother's face pattern. And I can write the numerator as x minus 4 times x plus 4, keeping the denominator as it was, x plus 4, because it's already completely factored. And notice what happens. Just like up here with the 6 and the 3 and the 2's, these cancel because they're the same number. If you have the same number in the numerator and the denominator as a factor, you can cancel them. They equal 1. And so I'm left with x minus 4. So 2 things just happened. One is I was able to discover, in fact, that x plus 4 is a factor of x squared minus 6, but I was able to do the division x squared minus 16, excuse me, I said 6 a moment ago, x squared minus 16 divided by x plus 4 equals x minus 4. I'm going to do long division just to make the point. I normally wouldn't. At this stage of the game, I would call it done and say, ooh, I know what the factor, I know what the value is when I divide x squared minus 16 divided by x plus 4, but let's do division just to kind of live with it, to really meld it in our head that that's what I'm doing. So remember, if I divide x squared minus 16, I have to put x squared plus 0x minus 16 inside. Remember, you have to have every version of x all the way across until you get to the constant. And I'm going to divide that by x plus 4. So what would I have to multiply x by to get x squared? Well, that would just be an x. And then I do the multiplication with the whole binomial. X times x is x squared. Again, got exactly what I wanted here. And then x times 4 is 4x. I want to subtract this number, which means I have to change all the signs inside and add. X squared minus x squared cancels. 0 minus 4x, negative 4x minus 16, bring everything else down. What would I have to multiply x by to get negative 4x? Negative 4. Negative 4 times x equals negative 4. Great, I got exactly the same number, which is what I want. And then negative 4 times positive 4 is negative 16. I want to subtract this number, which means change all the signs inside and turn it into addition. Negative 4 plus 4, 0. Negative 16 plus 16, 0. So when I divide x squared minus 16 by x plus 4, the answer is x minus 4. And I got the same exact answer when I did division by factoring. All right, one more really fast, without any checking, without a lot of talking. Let's just do it. Divide 5x squared minus 9y squared by, 25x squared minus 9y squared. And I'm going to divide it by 5x plus 3y using factoring. First step, suspect that I have a difference of 2 squares, and so I'm going to use the mother's face method. Can I write the first term in the numerator as something squared minus the second term in the numerator can I write it as something squared? Over, well, I'm just going to keep 5x plus 3y. 25x squared could be written as 5x quantity squared. If I drop that square onto the 5, I get 25, and onto the x, I get x squared. Same thing here, 3y. That looks good, so now let's factor. 5x minus 3y times 5x plus 3y. Check it out. This looks pretty promising because my denominator has one of the factors in my numerator. 5x plus 3y in the numerator and in the denominator cancels, and I'm left with 25x squared minus 9y squared over 5x plus 3y equals 5x minus 3y. Done.